In this video, we're going to look at scientific notation, how to express numbers in scientific notation, and do calculations in scientific notation. Scientific notation is n times 10 to the nth. The n is a value greater than or equal to 1 and less than 10. The nth is the exponent. If we look at a number like 4.15 times 10 to the fourth, that's in scientific notation. Our n is 4.15, and our nth, our exponent, is 4. Now we can express this as a normal number by starting with 4.15 and then considering the fourth exponent. We can move 4 positions, put the decimal place, fill in zeros, and we have that value. Another way of looking at this is to think about 4.15 times 10 to the fourth as taking 4.15 times 10 times 10 times 10 times 10. If we did that, you would see that we'd get 41,500. If we look at a value that has a negative exponent, such as 7.05 times 10 to the minus third, here what we're doing is starting with 7.05 and moving the decimal the other way. If we move the decimal 4, add in zeros, we'll have our value. Or we can think about this as 7.05 divided by 10 times 10 times 10. Now that was converting from scientific notation to normal notation. Let's look at converting a number like 526.1 into scientific notation. We will move our decimal place so that we only have a whole number 5. We are moving to the left, so therefore we're going to have a positive exponent. So therefore this would be 5.261 times 10, and we moved it 2 positions, so therefore it would be 5.261 times 10 to the second. If we look at a value like 0.00987, here let's move it until we just get a value between 1 and 10. We move that there, we see that that's moving it to the right. If we move the decimal to the right, we're going to have a negative value, so we get 9.87 times 10 to the minus third. Now that we've converted back and forth with scientific notation, let's look at addition and subtraction. In addition and subtraction, we need to have the same value of our exponent. So if we had two numbers, 1.20 times 10 to the second plus 5.26 times 10 to the third, we either have to convert this into 10 to the second or 10 to the third. Let's look at option 1. In option 1, we're going to convert to 10 to the third. The first thing we need to do is take our first value and convert it into the third to match the second value. To do that, we're going to move the decimal place 1 position. Moving it 1 position, we'll see that we're going to the left, so we're going to increase this by 1 and we'll go to 3. Then we add 5.26 times 10 to the third. Then we will add 0.120 plus 5.26 times 10 to the third. We do not have to convert our exponents because they are equal. That gives us our value, 5.38 times 10 to the third. If we look at our second option, here we're going to convert everything to 10 to the second. We can do either. They will both give us the same answer as you'll see in this example. So if we start with 5.26 times 10 to the third, if we convert that to 10 to the second, we're actually going to be moving our decimal place in 1, so we have 52.6. Now notice this is not an accurate scientific notation, but we can do this while we're doing our addition. If we then take our other value, again add the 1.2 to the 52.6 in this case, times 10 to the second, we will get 53.8 times 10 to the second. But we can't stop there because that's not the correct scientific notation. So we got to convert that to the correct value, and you'll see that this is the same value we had this first time. Subtraction works exactly the same way. We just have to have them in the same exponents, and then we can subtract the two numbers. Let's look at multiplication and division. In multiplication and division, to multiply, we're going to add the exponents. So if we take a rather large number, 6.022 times 10 to the 23rd, and we're going to multiply that by 1.25 times 10 to the minus 4th, what we're going to do in this case is we'll multiply the two numbers, 6.022 and 1.25, and then for our exponents, we're going to add those. So we're going to add 23 plus the negative 4. We do our multiplication, and we'll come out with 7.53 times 10 to the 19th. In division, we're going to do something very similar, except this time we're going to subtract our exponents. So therefore, 2.24 times 10 to the minus 12th divided by 6.81 times 10 to the minus 15th. Here, we're going to do our division of our numbers, and then we will take and subtract. So minus 12 minus 15. If we do our division and we do a subtraction, we'll see that we're going to end up with 0.329 times 10 to the third. Again, look at that value. Is that a correct scientific notation? No, it's not, so we're going to have to convert. Move this one decimal place. That's going to decrease our exponent, so we'll have 3.29 times 10 to the second.